this video we're going to look at how to graph a log function. In order to graph a log function, the easiest way is to look at the base of that log function. Whatever the base of the log function is, you can go back and first graph its inverse function, the exponential function, with the same base. So, we're looking at log base 2. I'm going to look at graphing first f of x equals 2 to the x power. So, the x values go in, the y values come out. For an exponential function, we're allowed to choose any x values that we want. So let's say -1, 0, and 1. So we'll do 2 to the -1 power, 2 to the 0 power, and 2 to the power of 1. 2 to the -1 power is the reciprocal of 2 raised to the +1 power, so I get 1/2. So I get the point -1, 1/2. 2 to the 0 power is 1, so we get the point 0, 1. 2 to the +1 power is 2, so I get 1, 2. So this is the exponential 0, 1. I have 1, 2. And was that -1, 1/2. Okay, so this is the graph of the exponential function. So this is not what we want, but this is the exponential, or the inverse of what we want. Let's keep a couple of things in mind as we do this, that the x-axis is acting as a horizontal asymptote. Let's also think of our domain and range. Okay, so the domain of an exponential is all real numbers, anything from -infinity to +infinity. And what comes out of an exponential is always from 0 to infinity, not including 0. Alright, so our goal was not to graph the exponential this time, but to graph the log function. So I'm going to do the log things in green. Alright, to graph the log function, which is the inverse of that exponential, all we have to do is take the x and y values of the exponential and then switch them around. So I'm going to take this point here and I'm going to flip it around. So instead of -1, 1/2, it's going to be 1/2, -1. So we're going to plot that point. Alright, and instead of being 0, 1, we're going to do 1, 0. We're going to graph that point. And then instead of being 1, 2, it's going to be 2, 1. So we're going to graph those 3 points. Alright, so x equals +1/2, y equals -1 would be right here. 1, 0 would be right here. 2, 1 would be right here. Alright, so the graph of the log function sort of looks like this. There we go. What else do we know here? Our domain of the log function should be what the range was of the exponential. So if we look at our graph, our domain goes from 0 to infinity. So that means that we don't have any x values at 0. And in fact, turns out that x equals 0 is a vertical asymptote. So if y equals 0 is the horizontal asymptote for the exponential, switch the x and the y. So instead of y equals 0, x equals 0, for the logarithmic function becomes a vertical asymptote. So that makes sense with our domain here from 0 to infinity, but the domain does not include an x value of 0. The range is going to be the domain of the exponential. So our range would be from -infinity to +infinity. Alright. So the key here is that if you would like to graph a log function, then graph the exponential first. So if you were asked, let's say, to graph f of x equals log of x. The base of that log would be 10, so I would first graph the inverse function. I would graph 10 to the x power. So I would graph the exponential first, and then use those points to graph the log. If I was going to graph, let's say, a natural log function, then I would first graph the inverse function. I would graph the exponential with the same base. The base of ln is base e. Remember, no number with log is base 10. If you see ln, that's base e. So I would graph e to the power of x first, and then use those order pairs, switch them around to graph the natural log function. So start with the exponential, make a t-chart, switch all the ordered pairs around, and that's going to give you the graph of the log of the same base. Alright, here's some kind of a summary of what you're going to see for exponentials and logs and how they compare. The domain of an exponential is negative infinity to positive infinity always, and that means that the range, we'll switch this around, that means that the range of the logarithm will always be exactly the same thing. The range of the log will always be from negative infinity to positive infinity. If the range of the exponential is from 0 to infinity, then the domain of the log is from 0 to infinity. Exponentials always have a horizontal asymptote at y equals 0. The logarithmic functions are always going to have a vertical asymptote at x equals 0. Okay, and I've just listed a few key points that you're going to see on each graph, and then when you flip them all around, you get the key points on the graph of the logarithmic function.